Hello, this is checkpoint 4.40. They want us to use Lagrange multipliers to find the minimum value of x squared plus y squared plus z squared, subject to the constraint. There's two constraints now. There's 2x plus y plus 2z is equal to 9, and 5x plus 5y plus 7z is equal to 29. Let's get all this stuff down. We got f of x, y, z, function of three variables, x squared plus y squared plus z squared. We got a couple of constraints, a couple of planes here. We have 2x plus y plus 2z is equal to 9, and 5x plus 5y plus 7z is equal to 29. Okay. Now, I think we should know the formula for, so when we have two constraints, Lagrange multipliers tells us that we want to find the solution for the gradient of f being equal to the linear combination of the gradients of these two functions. So maybe we should call these functions g of x, y, z and h of x, y, z. So then we want the gradient of f to be equal to some lambda 1 of g, the gradient of g, plus lambda 2 times the gradient of h. So we're going to need to take some derivatives, introduce two new scalars, the lambda 1 and lambda 2, and set up three equations out of these two, out of this equation. We'll get three equations, and lambda 1 and lambda 2 will introduce two more, so that would be 5 unknowns. And if we throw in these two constraints, then we will have our 5 equations and 5 unknowns. All right, first let's find the gradient of f. That's quite simple. It's 2x, 2y, 2z. And the gradient of g is going to be just a constant, 2, 1, 2. And the gradient of h, another constant, 5, 5, 7. Okay. Now let's put that together into three equations. We have 2x is equal to 2 lambda 1 plus 5 lambda 2. And then we have 2y is equal to the middle one. So that's lambda 1 plus 5 lambda 2, and then 2z is equal to the last one, 2 lambda 1 plus 7 lambda 2. So we have three equations, 5 unknowns at this point, and we have these other two. So I think one idea with this, for solving for this, and there's a lot of different ways to solve for this, so we just have to find, a good way to do it. But one idea is to solve for x, y, z here, and then put it back into these two equations, and we'll have these two equations in terms of lambda 1 and lambda 2, and then you can solve for lambda 1 and lambda 2, and then put it back in here. That's one way to do it. Again, many different ways. So let's solve for x, y, and z. Let's divide everything by 2. So we have x is equal to, I wonder if we should just put 1/2. Let's just put 1/2, and then the rest of this stuff, 2 lambda 1 plus 5 lambda 2, and y is the same thing, 1/2 times lambda 1 plus 5 lambda 2, and z is equal to 1/2 2 lambda 1 plus 7 lambda 2. Okay, I wish they were even so that that would divide out nicely, but they're not. So let's put it back into the g and h function. So into the g function, we're gonna have 2 times 1/2 2 lambda 1 plus 5 lambda 2 plus y 1/2 lambda 1 plus 5 lambda 2 plus 2z, and that would be 1/2 2 lambda 1 plus 7 lambda 2, and that's equal to 9. Alright, that's our first super long equation. The second one is going to be 5 times all this stuff. It's 2 lambda 1 plus 5 lambda 2 plus 5y, 5 times 1/2 lambda 1 plus 5 lambda 2, and then 7z, 1/2 2 lambda 1 plus 7 lambda 2 is equal to, this one is equal to 29. Okay, a bit of a big mess. Let's work all this stuff out. Actually, I did it off on the side already, so maybe we'll just go with those equations that I got. So for the first one, for the g function, oh, this one's the h function. For the g function, it looks like I ended up getting 9/2 times lambda 1 plus, this is 31/2 times lambda 2 is equal to 9. And then for the second one, it looks like I got 29 over 2 lambda 1 plus 62 lambda 2 is equal to 29. All right. Well, if we can try to avoid dealing with fractions, that'd be great. So that's as simple as multiplying both equations by 2, and it looks like I will get a 9 lambda 1 plus 31 is equal to 18, and then here I will get a 29 lambda 1. 62 times 2 is 124. Oops, there should be a lambda 2 here. So that's 124 lambda 2, and 29 times 2 is 58. Okay, still trying to solve for this. Let's see, looks like I might have solved for lambda 1 here. We can combine equations again, but looks like if we solve for lambda 1 here, lambda 1 is equal to 18 minus 31 lambda 2. Let's see, there you go, 18 minus 31 lambda 2 divided by 9. And let's stick that into this equation here, and we will get 29 times that stuff that we just got, 18 minus 31 lambda 2 over 9, plus 124 lambda 2 equals 58, and then solve for lambda 2 somehow, and I think I ended up getting lambda 2 equals 0. So if lambda 2 is equal to 0, this would be 18 over 9. That makes lambda 1 equal to 2. Remember that these are the least important out of the 5 unknowns. What we want to do is we want to put it all back into x and y and z. So let's put these back into the x and y and z, and we get x equals the important part. So 0 in for lambda 2 and 2 in for lambda 1. So this will give us 2, x is equal to 2, y is equal to 1/2 times 2, that's just 1, and this will be 2, this will be z is equal to 2. So we have these three values that we really want, and so we'll put that into the equation, back to the original equation here. So we have f of 2, 1, 2, and that would be 2 squared plus 1 squared plus 2 squared, so that's 4 and 4, that's 8 plus 1 is 9, and that is your max value. Okay, all right, I hope that helps.